So here we have two different types of motion. One is uniform motion and second is circular motion, as we had discussed in the previous class. So what is uniform motion, Yashika? Speed of an object does not change. Object covers equal distance in equal intervals of time. It's called uniform motion. And a circular motion is the one where the object moves about a fixed point and at a fixed distance. It moves about a fixed point. Around a point, it moves. And when we say that object is moving in uniform circular motion, it means that object is moving in a circle with constant speed. So if the object moves in a circle with constant speed, then it is uniform circular motion. But we know that in circular motion, object changes its direction at every point. So how do we find direction of an object which is moving in circular motion? By no, direction is along the tangent to the circle. We consider the position of a particle at certain point and we draw a tangent there. So tangent indicates the direction of motion of the particle at that point. And we see that if we draw the tangent at different points on the circle, then it is different at different positions, right? So direction changes at every point. And because direction changes and therefore velocity also changes. Okay. So next we have relation between linear speed and angular speed. How are linear speed and angular speed related? So linear speed is the one where we talk about displacement and time, and angular speed is the one where we talk about angle and time, right? Now we are going to find the relation between these two quantities. So we'll consider a particle performing uniform circular motion along the circumference of a circle of radius r. Okay? So we have a particle here at A, and it is moving along the circumference of the circle like this. Radius is r. So let linear velocity or linear speed, let's take speed because velocity is different at different points. We can take speed. So it is moving with constant linear speed because it is uniform motion. Therefore, object is moving with constant linear speed and angular speed omega. Okay. So in small intervals of time del t, the particle moves from A to B. Let's say that after a small interval of time, initially particle was at A. And after a small interval of time del t, it goes to point B, it reaches point B. And in this time interval, it covers an angle. The angular displacement of the particle during this time interval is del theta. And linear displacement is del S. Okay? So it covers a linear distance del S and the radius vector rotates through an angle del theta in this small time interval. Okay. So therefore, because as we know theta is L by R, right? So we can write S in terms of R and theta. Here in place of L, we have taken S as a variable, right? We can choose any variable as per our convenience. So theta is L by R or S by R. Okay? We can write S by R. So S is R theta. So for small angular displacement, we can write linear displacement as del S and it is equal to R del theta. Now we are going to differentiate it with respect to the time interval which was given to us. Okay. So this del S by del T is nothing but V. But before this, we need to, we'll take a small interval of time. We'll make it ds by dt first and then we'll write V for this. Okay, so differentiate it first and then put the limits. Del t tends to 0, both sides, and we'll get this. ds by dt is equal to r d theta by dt. Now this ds by dt is the linear speed. Yes, because it is constant. Linear speed is constant. And d theta by dt is angular speed. So we can relate these two quantities as this. V is equal to r omega. Okay, V is equal to r omega. R is the radius of the circle along which the circumference, देखा था ना अभी हमने कि जो particle जो है, it was moving along the circumference of the circle of radius r. Okay, and V is the linear speed, omega is the angular speed, and we can relate all these three quantities like this. So in vector form, if I want to write, because angular velocity is linear velocity and angular velocity, these are vector quantities. So we can write these as vector v is equal to vector omega cross vector r. V is omega cross r. Okay. So look at the direction. As I had said that when particle moves in a circle, then we can take the tangent. We can draw a tangent to the circle. And tangent tells us about the direction of motion of the particle at that point. You can see we have different direction at different point of time. At different positions of the particle, we have different direction of motion. So direction changes at every point when a particle moves in a circle. So linear velocity and this is one thing. Direction changes at every point, and therefore v is, v will also change because direction is changing. And linear velocity, you can see it is always perpendicular to the radius vector. Vector v and vector r, they are always perpendicular to each other because tangent is perpendicular to the radius. This we had done in lower classes in maths. Mathematics mein kiya hai na? The tangent and the radius, they are perpendicular to each other. So v and r, they are always perpendicular to each other. We can see here in this figure. And angular velocity is perpendicular to the plane of radius vector and linear velocity. Angular velocity is perpendicular to both the plane which consists of radius vector and linear velocity. Plane carrying both r and v. It is perpendicular to both. Okay? It is perpendicular to both r and v. So velocity is a vector quantity, therefore it has magnitude and direction. So in uniform circular motion, magnitude of velocity is constant, magnitude of velocity is speed, it is constant, while velocity is variable because direction changes at every point. However, the direction of velocity keeps on changing as discussed. Direction changes at every point, and therefore velocity is also changing, and therefore we say that uniform circular motion is accelerating. Okay? Uniform circular motion is an accelerated motion. Why? Because there is change in velocity. And why there is change in velocity? Because direction of motion changes at every point. And because direction changes at every point, therefore velocity also changes at every point. And whenever there is, whenever there is change in velocity, there is acceleration. So uniform circular motion is accelerating. Let's do the questions based on this. Relationship between angular speed and linear speed. Vector v is equal to vector omega cross vector r. Uniform circular motion is an accelerated motion. True or false? The direction of velocity in uniform circular motion becomes zero, constant, changing, none of the above. Changing is the correct answer. Direction changes at every point because you can see that how do we find direction? By drawing a tangent at the position. Now do this question. A circular disc is rotating about its own axis at uniform rate. Completes 30 rotations in 1 minute. The angular velocity of disc in radian per second is. We have number of rotations is given, it is 30. Time is given 1 minute, 1 minute and 30 rotations, right? We have to find angular velocity. How do we find angular velocity? It's 2 pi n. Angular velocity is 2 pi n. And what is n? N is the number of rotations per second. For angular velocity, n is the number of rotations. per second. And if we have linear velocity, if we have only number of rotations, then it's theta. Theta is 2 pi n, where n is number of rotations. This we had discussed. And if we have number of rotations per second, then it is omega. Okay. Your options are 2 pi, pi, pi by 2, pi by 4. How will you do this? Omega is theta by t. Okay. And how will we find theta? 2 pi n. N is number of rotations. Theta is 2 pi n. N is number of rotations and time is given, it is 1 minute. In 1 minute, we have 60 seconds. Put the values, you'll get your answer. Answer is pi. Okay. Let's move to the next question now. A particle is moving with uniform speed along a circle of radius 20 centimeter. If angular velocity of particle is 5 radian per second, then its speed is, these are the options: 25 meter per second, 5 meter per second, 1 meter per second, 0.2 meter per second. Radius is given, radius is 20 centimeter. So we can convert this radius into meter. And angular velocity is given, it is 5 radian per second. We have to find speed. You know the relation? V is equal to R omega. Yes. Now put the values, it's 0.2 for radius and 5 radian per second omega is given. You just have to multiply these two to get the correct answer. It's 1 meter per second. Okay, so correct option is third option, 1 meter per second. Next question. A particle is moving with uniform speed 0.5 meter per second along a circle of radius 1 meter, then angular velocity of the particle is 2 radian per second, 1.5 radian per second, 1 radian per second, 0.5 radian per second. Again, we'll use the same formula. V is equal to R omega. Okay, R is given, it is 1 meter, speed is 0.5 meter per second. Just put the values, you'll get omega as 0.5 radian per second. So option 4 is the correct option. Okay. Any doubt? Easy questions are direct questions. Next question. A particle is moving along a circle and its linear velocity is 0.5 meter per second. When its angular velocity is 2.5 radian per second, its tangential acceleration is given, it's 0.2 radian per second square. Then its angular acceleration is. Your options are 1 radian per second square because it is angular acceleration, right? 2 radian per second square, 2.5 radian per second square, 3 radian per second square. See, as we have angular velocity, in the same way we can find angular acceleration, no? So linear velocity V is given, omega is given, tangential acceleration is given, A is given, we have to find alpha. So for this, we need to find R first and then we can relate alpha and A. Okay. As we relate V and omega in the same way, we can relate A and alpha. कैसे relate करोगे? V R omega होता है. V is R omega. Now put the values. You'll get the value of radius. Linear velocity is given. It is 0.5. Angular velocity is 2.5. So radius is. You're not doing? हो गया? अच्छा समझ रहे हो. ठीक है? So now we can, in the same way as we have related linear velocity with angular velocity, in the same way we can relate linear acceleration with angular acceleration. So our linear acceleration is A, while angular acceleration is alpha. ठीक है? जैसे आपका V is equal to R omega है, तो V क्या है? Linear velocity. Omega क्या है? Angular velocity. ऐसे ही A R alpha हो जाएगा, उसके corresponding. V के प्लेस पे ए को रिप्लेस ए से रिप्लेस किया एंगुलर लीनियर एक्सेलरेशन और ओमेगा को अल्फा से। ठीक है, सिमिलर है ना, एक जैसा सही लग रहा है। तो A is R alpha. So alpha is AT by R, tangential acceleration by R. See, this is not radial acceleration. Radial acceleration होता है आपका centripetal acceleration, which acts towards the center. When an object moves in a circle, then there are two kinds of acceleration acting on the object. One is tangential and other is radial. Tangential acceleration कहाँ act करता है? जो direction of motion है उसके along, where the velocity vector points in the same direction, tangential acceleration points with the tangent points. जहां टेंजेंट है, जहां डायरेक्शन ऑफ मोशन है, जहां वेलोसिटी वेक्टर का डायरेक्शन है, वहां पे आपका टेंजेंशियल एक्सेलरेशन पॉइंट करता है. व्हाइल रेडियल एक्सेलरेशन इट एक्ट्स टुवर्ड्स द सेंटर of the circle. Okay, so here we're talking about tangential acceleration, not radial one. Is this clear? So AT, that's why I've written this T, subscript T here. So alpha is AT by R. Again, we'll put the values and we'll get angular acceleration as 1 radian per second square. Option 1 is the correct answer. Clear? Let's move to the next question. The linear and angular velocity of a body in rotatory motion are 3 meter per second and 6 radian per second respectively. So V is given, omega is given, linear acceleration is given, it's A 6 meter per second square. We have to find angular acceleration in radian per second square. And your options are 6, 10, 12, 2. To this question now. First find R. R is in meter, right? 0.5 meter. And now find alpha. The way you have related these two terms, V and omega, in the same way we can relate alpha and A. How are they related? A is equal to R alpha. And what type of acceleration is this? Linear or tangential or radial? It's tangential. Okay. So A is R alpha. Again, A is 6. It is given to us. Linear acceleration is 6 meter per second square is equal to R is half into alpha. You'll put the values. You'll get your answer as 12. So option 3 is the correct answer. Clear? Any doubt? करण आज कम बोल रहे हैं. What's going on? समझ तो आ रहा है ना? आपके फ्रेंड्स नहीं आए आज, अकेले रह गए आप. So UCM, uniform circular motion, as periodic motion. Periodic, it repeats itself. Periodic motion is the one which repeats itself. Which repeats after regular intervals of time is called periodic motion. Any motion which repeats itself in equal intervals of time is called periodic motion. For example, this motion, oscillatory motion, you can see this bob is oscillating about a fixed point and it is moving to and fro, right? So it is a periodic motion. A particle performing uniform circular motion moves continuously along the same circle and the time taken by it to complete each circle is always constant. We call that time as time period of rotation, right? Therefore, uniform circular motion is also periodic. Okay, look at this. So these are the examples where this motion repeats itself after a fixed interval of time. This in case of Earth, Sun system. Earth rotates about its axis. In 24 hours, it completes its one rotation and revolution is completed in 365 days. 365.25 days. Right? So it is periodic motion. It repeats itself. After a fixed interval of time, we see the motion, same position, same motion again. Okay. In the same way, in case of a clock, this motion repeats itself after every 1 hour. Yes. And in 24 hours, we get the same time. And in 12 hour clock, in 12 hours, we get the same time if you do not consider AM, PM. So it is also periodic. Period of revolution. Revolution means one round around an object. So period of revolution is the time taken by the particle to complete one revolution is called period of revolution. If you consider a circle of radius r moving with linear velocity v, this object, which is blue in color, it is moving about a fixed point. Fixed point is red in color. It is moving about this fixed point. Okay. And so time period is distance upon speed. So what is the distance covered by the particle in one revolution? It's 2 pi r, circumference of the circle, and speed is v. So we can write time period as 2 pi r by v, because circumference is 2 pi r and speed is v. And how are v and omega related? It's v is equal to omega r, right? So we can also write, in place of v, we can write r omega. है ना? V क्या होता है? Omega r. So you have v in the denominator. In place of v here, we can write omega r. So r क्या हो जाएगा? Cancel. और t क्या आ जाएगा? 2 pi by omega. Omega is angular velocity. And frequency of revolution is denoted by n. Frequency of revolution is, how will you define frequency of revolution? The number of revolutions performed per unit time by a particle in uniform circular motion is called frequency of revolution. Unit time में कितने revolutions हुए? ठीक है? Unit time में कितने revolutions हुए? And in time t, the particle completes one revolution. है ना? Time taken to complete one revolution is time period, right? So in unit time, it will complete 1 by t revolutions. It completes one revolution in time t. One revolution in time t, or we can say in time t. T में एक revolution हुआ, तो unit time में कितने revolutions हुए? 1 by t. Okay, so we can write frequency as 1 upon t, because t is 2 pi by omega, and therefore we can write frequency as omega by 2 pi, or we can write omega as 2 pi n. N is frequency, omega is angular velocity. Frequency is number of revolutions in a unit time. And what is the SI unit of frequency? Hertz. It is denoted by capital H, small c. Now we have questions based on this. The number of revolutions performed per unit time in UCM is called period of revolution, frequency of revolution, both A and B, none of the above. Frequency of revolutions. Next question, SI unit of frequency is called both A and B, because frequency is 1 upon t, so per second is also a unit. Per second and hertz, right? Period of revolution is given by number 1, 2 pi r by v, 2 pi by omega, c is omega by 2 pi, both A and B. Time period of revolution is both A and B. 2 pi r by v circumference और linear velocity क्या था, और फिर b को हमने लिखा था r omega, r cancel हो गया था, और 2 pi by omega is also correct. Centripetal acceleration क्या होता है? Acceleration that acts towards the center. Okay. See, consider a particle revolving with uniform speed, angular speed. Okay, uniform angular speed means constant angular speed omega along the circle in XOY plane. This particle is moving in 2 dimensions in XOY plane, and let O be the center of the circle, and we are considering center at the origin. ठीक है, हम center को origin पे consider कर रहे हैं. Let R be the radius of the circle. Suppose a particle from A and it reaches point P after some time t. It covers this much linear distance. Okay, AP, arc AP cover कर रहा है वो. From A to P. It goes to P in time t. Now we can draw a perpendicular from P on XY axis. Okay, like this. So PM is the perpendicular on x-axis and PN is the perpendicular on y-axis. Vector R. OP is vector R, position vector. OP is the position vector, radius vector R. Okay. And PM is the perpendicular which is drawn from the position of the particle, the present position of the particle on x-axis. And PN is the perpendicular drawn from P to N on y-axis. Okay. Now we can resolve this vector into components. है ना, कंपोनेंट्स में रिजॉल्व कर सकते हैं, पोलर कोऑर्डिनेट्स में, कार्टेशियन कोऑर्डिनेट्स में वी कैन राइट. How do we write vector r in terms of polar coordinates, or sorry, Cartesian coordinates? If xy, if we consider xy as the coordinate of the position of the particle, then we can write vector r as xi cap plus yj cap. Okay, and this vector r makes an angle theta with the x-axis. ठीक है, so angle POM is theta and theta is omega t. As we write s is equal to vt, है ना, डिस्टेंस क्या होता है, स्पीड इनटू टाइम, s is v into t. In the same way we can write theta as omega into t. Omega is theta by t. Angular velocity is angle upon time. Omega is theta by t and therefore theta is omega t. I hope this is clear. ठीक है, so radius vector at time t is given by this. These are the Cartesian coordinates. We are writing in terms of Cartesian coordinates. Vector r as, we can write vector r as xi cap plus yj cap. I cap and j cap are the unit vectors along x-axis and y-axis respectively, right? Look at this triangle POM. Consider this triangle POM. In this triangle, we have this angle POM theta. PM is the perpendicular and OM is the base, right? PM is the perpendicular, OM is the base. So now we can resolve R into polar coordinates. Yes, so we can write x as R cos theta. कर सकते हैं पोलर कोऑर्डिनेट्स में रिजॉल्व, या नहीं कर सकते? कर सकते हैं ना. अच्छा, इसको ऐसे भी अंडरस्टैंड कर सकते हो, और x अपॉन r क्या है, cos theta, base upon hypotenuse. No, x is base, r is hypotenuse, so x upon r is cos theta, so we can write x as r cos theta and theta is omega t. Why omega t? Because angle है, velocity into time होगा. ठीक है. In the same way we can write for y r sin theta and theta is again omega t, so it's r sin omega t. So in place of x, now we'll write r cos omega t, and for y we are writing r sin omega t. Now we have written our position vector, our radius vector in terms of polar coordinates. Initially we had written in terms of Cartesian coordinates. Now we are writing in terms of polar coordinates. ठीक है, अब क्या करेंगे? Linear velocity of the particle v क्या होता है, dr by dt. We had found out, we had written the expression for r in terms of polar coordinates, we had written, है ना, in the previous slide. So we can easily differentiate it with respect to t. So it's d by dt. In the bracket we'll write vector r as r cos omega t I cap plus r sin omega t j cap. यही किया था ना हमने, x की जगह पे r cos omega t, y के प्लेस पे r sin omega t. ठीक है, अब इसको डिफरेंशिएट करोगे. r is a constant, it is a radius, it is a constant. Cos omega t and sin omega t we can differentiate with respect to t. ठीक है, when you differentiate, what will you get? We can only differentiate cos omega t and sin omega t because these are the functions of time and r is a constant. So move r outside the bracket, and in the bracket we'll have this. Now let's differentiate this. We are finding dr by dt, and dr by dt is linear velocity. में देख रहे हो कितना उठे हुए हो, क्या फाइंड कर रहे हैं, लीनियर या एंगुलर? आपने अभी किसको डिफरेंशिएट किया, dr by dt किया ना, हाँ, तो v फाइंड कर रहे हैं, v इज dr by dt। मैं दे रही हूँ कॉपी हो रहा है या फिर अंडरस्टैंड करके लिखा जा रहा है? ठीक है, अब क्या आएगा? Now differentiate this cos omega t on differentiating. We get cos becomes minus sin omega t। तो यहाँ पे कौन सा रूल अप्लाई करोगे आप डिफरेंशिएशन का? कौन सा रूल होता है? चेन रूल जैसा कुछ होता है, उसके अंदर वाला डिफरेंशिएट करते हैं फिर है ना, है ना। तो पहले cos ओमेगा टी को लिखेंगे माइनस साइन ओमेगा टी, एंड देन वी विल डिफरेंशिएट ओमेगा टी विद रिस्पेक्ट टू टी। ओमेगा इज अ कांस्टेंट, है ना। तो ओमेगा टी को डिफरेंशिएट करोगे टी के रिस्पेक्ट में, तो ओमेगा आ जाएगा माइनस ओमेगा साइन ओमेगा टी, ओके, प्लस जे कैप। नाउ डिफरेंशिएट साइन ओमेगा टी विद रिस्पेक्ट टू टी, cos omega t into d by dt of omega t, it's omega cos omega t, okay। This is one of the rules in differentiation। अगर आपको t के रिस्पेक्ट में डिफरेंशिएट करना है एंड यू हैव समथिंग लाइक ओमेगा टी हियर एज इन दिस केस, तो पहले हम देखते हैं बाहर साइन है तो साइन का कॉस करते हैं, फिर उसके अंदर क्या है, ओमेगा टी है, फिर ओमेगा टी को फर्दर डिफरेंशिएट करते हैं टी के रिस्पेक्ट में और ओमेगा आ जाएगा। ठीक है, तो ओमेगा इंटू कॉस ओमेगा टी हो गया, ओके। दिस इज व्हाट वी आर गेटिंग हियर, दिस इज b minus I cap r omega sin omega t plus j cap r omega cos omega t। Please write this। As we have found out velocity, so from velocity we can find acceleration। Velocity कैसे आया? By differentiating the position vector we get velocity vector, right? When we differentiate position or radius vector we get velocity vector, and when we differentiate, देखो आपने किसको differentiate किया? Radius को। अभी हम क्या find कर रहे हैं? Acceleration। Acceleration के लिए we have to differentiate velocity, so a is dv by dt। जो भी एक्सप्रेशन आपका v का आया था उसको यहाँ पुट करो, you'll get this। r is constant, omega is a constant, we can move these two constants outside the bracket, and we only have to differentiate sin omega t cos omega t, okay, because these are the functions of time। So r omega outside the bracket, in the bracket we'll write minus I cap sin omega t and j cap cos omega t। r omega belongs to both the terms, है ना, तो उसको हम कॉमन लेके बाहर ले सकते हैं, नो। अब when we differentiate sin omega t, what do we get? Omega cos omega t। Omega cos omega t, yes। Omega cos omega t, put this value here, plus j cap, and when we differentiate cos omega t, then yes, minus omega sin omega t, we're going to put this value here. Again we have omega, we can move this omega outside the bracket, and we have negative sign also, okay। So in the bracket we have r cos omega t I cap plus r sin omega t j cap। ये क्या था? ये वेक्टर r है ना, r है ना, ये देखो इनिशियली r क्या था, r से v निकाला डिफरेंशिएट करके, and then on differentiating v we have got this a। So we can see that in the bracket the expression that we have got is actually the position vector r। So we can write this as minus omega square vector r। This is centripetal acceleration, and how do we get centripetal acceleration? By differentiating radius vector twice, है ना। Any doubt? So it's minus omega square vector r. Now negative sign shows that the direction of the acceleration is opposite to that of the radius vector. See, radius vector acts outwards, away from the center. Radius vector is away from the center. And acceleration is negative omega square r. So it shows that both vector r and vector a, they have the opposite directions. If radius vector is pointing away from O, so A will point towards O. Centripetal acceleration acts towards the center. Radius vector acts away from the center. While centripetal acceleration acts towards the center. So we have a negative sign, it shows this. And the magnitude of A is omega square r. Omega r is V, right? Omega r is V. So we can also write A as V square by r. You just multiply omega square r by r and divide this by r. Multiply and divide this expression by r. So in the denominator, you will get omega square r square, while in the, numerator, while in the denominator we'll have r. So omega square r square is V square. So it's V square by r. नहीं आया समझ? नहीं आया? आपने मल्टीप्लाई और डिवाइड करना है ओमेगा स्क्वायर आर को बाय आर, है ना? तो ओमेगा स्क्वायर बाय आर हो जाएगा. ओमेगा स्क्वायर बाय आर. ओमेगा स्क्वायर इज वी स्क्वायर. So it's v square by r. This is the direction of acceleration. It acts towards the center while radius vector acts away from the center. You can see they have the opposite directions. Now we have questions based on this. The radial acceleration of a particle in vector form is given as this. Yes. Minus omega square vector r. The radial centripetal acceleration for a circular motion is directed along the radius towards the center, along the radius away from the center, along the radius towards or away from the center, tangentially to the circle. Tangential to the circle. Along the radius towards the center is the correct answer. Next, we have centripetal acceleration using vector method. Again, consider a particle performing uniform circular motion with linear speed v and angular speed omega along a circle of radius r. So we have a particle, it moves from point A to point B in a very short time interval del t, and it raised small angle del theta. Okay. Let vector AP and BQ represents the velocity vector v1 and vector v2 of the particle at point A and B respectively. So at point A, velocity of the particle is vector v1, while at point B, velocity of the particle is vector v2. See, we can have different velocities because direction is changing. Speed is constant, but direction is changing, and velocity is speed plus direction. And though speed is constant, but direction changes at every point, and therefore velocity also changes. So we have different velocities at different points. Now draw BS equal and parallel to AP. Draw a line SQ. Okay, like this. So vector BS plus SQ is equal to vector BQ. So which law we have used here? Which law of addition, huh? Vector addition. It's triangle law of vector addition. So two vectors are in continuation. They are in order, and one vector is in opposite order. We can write one vector as sum of the two vectors which are in continuation, right? है ना? ये होता है ना triangle law of vector addition. Vector BS plus SQ, you can see BS का जो end है, जो head है, it coincides with the tail of QS. So they are in the same order. While this BQ, it represents the resultant vector, no? So we can write SQ as BQ minus BS, or BS and AP, they are parallel. So we can write AP in place of BS. So it's V2 minus V1. Vector V2 minus vector V1. SQ is vector V2 minus vector V1. BQ, vector BQ is V2 and vector AP is V1, no? These are the velocity vectors. आपका BS और AP इक्वल है, हमने ये बाय कंस्ट्रक्शन किया है, ठीक है? So change in velocity in time del T is del V. So this is del V. ठीक है? Now when the radius vector rotates through an angle del theta, the tangent also rotates through the same angle. अगर आपका रेडियस वेक्टर रोटेट कर रहा है एंगल डेल थीटा पे, तो टेंजेंट वेक्टर भी सेम एंगल पे रोटेट कर रहा है. लुक एट दिस एंगल डेल थीटा, दिस एंगल. तो देखो, आपको नहीं समझ आया होगा, ये आया या नहीं आया? नहीं आया ना, मुझे पता था. अब बहुत ध्यान से सुनना. आपका इनिशियल पोजीशन जो है पार्टिकल का वो ए है, राइट? इन टाइम डेल टी इट मूव्स टू पॉइंट बी. Angular displacement of the particle, look at the movement of cursor. Angular displacement of the particle is del theta. ये क्लियर हो गया था. अब हमने क्या किया? We have considered at position A, जो इनिशियल पोजीशन थी पार्टिकल की वो A है, तो पोजीशन A पे उसकी वेलोसिटी क्या है? वेक्टर V1. पोजीशन B पे उसकी वेलोसिटी वेक्टर BQ. These are different velocities V1 and V2, right? अब हमने क्या किया? हमने AP जो उसकी इनिशियल वेलोसिटी थी उसके पैरेलल वेक्टर एक ड्रॉ किया BS, और BS और AP इक्वल है, तो अगर ये V1 है तो ये भी V1 है. फिर हमने इन दोनों को ज्वाइन कर दिया, बिकॉज ये दोनों वेक्टर्स कॉन्टिन्यूएशन में है, इसलिए हमने ट्रायंगल लॉ ऑफ वेक्टर एडिशन लगाया और हमने बोला कि हमारा जो ये वाला वेक्टर है कि डेल V है एंड इट इज V2 माइनस V1. अब हम ये कह रहे हैं कि जैसे ये रेडियस वेक्टर है तो ये रोटेट किया बाय एंगल डेल थीटा, तो ये जो यहाँ पे टेंजेंट है ये ऐसे था परपेंडिकुलर टू रेडियस, तो टेंजेंट भी डेल थीटा मूव करेगा. मतलब ये जो देखो इनिशियल डायरेक्शन क्या है टेंजेंट वेक्टर की, ये जो एपी की डायरेक्शन है, एपी क्या है? इनिशियल टेंजेंट है, और बीक्यू क्या है? फाइनल टेंजेंट है. तो जो एपी इनिशियल टेंजेंट है और वो बीएस भी तो उसी को रिप्रेजेंट कर रहा है, उसी सेम डायरेक्शन को जिसको एपी रिप्रेजेंट कर रहा है. तो ये इनिशियल टेंजेंट की डायरेक्शन को ही तो रिप्रेजेंट कर रहा है बीएस, और बीक्यू किसको रिप्रेजेंट कर रहा है? जो फाइनल पोजीशन पे टेंजेंट है उसकी डायरेक्शन को, है ना? ये फाइनल टेंजेंट को रिप्रेजेंट कर रहा है. तो हम कह रहे हैं कि जितना रेडियस वेक्टर मूव किया यहां से यहाँ, उतना ही हमारा टेंजेंट भी जो है वो भी उतना ही रोटेट करेगा जितना रेडियस वेक्टर रोटेट करेगा. Therefore, the triangles AOB and QBS. Look at these triangles. AOB and QBS. These two triangles are similar triangles. These two triangles are similar triangles. So in triangle BSQ, del V is V del theta. Differentiating del V with respect to del T, we get this. ठीक है, तो आपका ये आ जाएगा, लिमिट्स लोगे आप tends to 0, then you can write this. So dV by dt is V d theta by dt, and dV by dt is acceleration, d theta by dt is omega. So A is equal to V omega. ठीक है, क्लियर है? In place of V, we can write R omega, so it's omega square R. The direction of acceleration is same as that of del V or SQ. अगर हम del T tends to 0 करेंगे, मतलब बहुत ही छोटा टाइम tends to 0 वाला टाइम, तो A और B जो है वो, जैसे A था फिर del T टाइम में B हुआ, A del T टाइम में B हो गया. अगर हम del t tends to 0 करेंगे तो a और b nearly coincide करेंगे and sq will be along the radius towards the center. जो sq ऊपर है वो along the radius हो जाएगा. In vector notation, acceleration is given by this. The acceleration of a particle performing uniform circular motion is always directed along the radius towards the center. Hence, it is called radial or normal or centripetal acceleration. ठीक है, इसको radial acceleration भी बोलते हैं. It acts towards the along the radius है, acts towards the center है, but along the radius है. और इसलिए इसको radial acceleration भी बोलते हैं. इसको normal acceleration भी बोलते हैं, and we call this centripetal acceleration as well. Okay. Yeah, आगे. And negative sign shows that direction of acceleration is opposite to that of radius vector. This we have discussed. Let's do the question. Centripetal acceleration is also called as both A and B, both radial and normal acceleration. Very good. Next question. A particle is moving along a circle with uniform speed. The following physical quantity is constant both in magnitude and direction. Velocity, centripetal acceleration, centripetal force, angular velocity. यूनिफॉर्म स्पीड से मूव कर रहा है तो कौन सी क्वांटिटी कांस्टेंट रहती है मैग्नीट्यूड में भी और डायरेक्शन में भी. Angular velocity, this we have discussed in previous class as well. Now another question. Two particles of masses in the ratio 1:2 are moving in circles of radii in the ratio 2:3 with time periods in the ratio 3:4. The ratio of their centripetal force is, सबके ratios given है आपको, ठीक है, 9:4, 1:4, 9:16, 16:27. Very good question. देखो, centripetal acceleration is omega square r. Omega is 2 pi by t. Centripetal force क्या होगा? M into centripetal acceleration. Centripetal force is M into centripetal acceleration, means M omega square r, or we can say mv square by r, right? We know the relation between omega and time period. Masses का ratio given है, radii का ratio given है, time periods का ratio given है, and centripetal forces का ratio find करना. ठीक है, this is how we write centripetal force. M into centripetal acceleration, mass into omega square r. ठीक है, and omega is 2 pi by t. Omega square is 2 pi by t whole square. So it's 4 pi square by t square. So you can see this centripetal force depends on mass, it depends on radius, it depends on time period as well. So it is directly related to mass and radius, while it is inversely related to square of time period. Okay, so F1 by F2 we can find out. F1 by F2 is this. M and R, they are directly related. तो आप देख सकते हो यहाँ पे subscript 1 है, तो here we have subscript 1 1. But for time period we are writing 2 because it is inversely related. In the same way we are writing for F2. Now we have these ratios given. We can put the values, simplify it, and this is the final answer that we'll get. 16:27. Particle is moving at uniform speed 2 meters per second along a circle of radius 0.5 meter. The centripetal acceleration of the particle is, speed is given, radius is given, we have to find centripetal acceleration, and your options are these. Uniform speed is given, radius is given. How do we write A in terms of speed and radius? V square by r. We simply have to put the values to get the answer. It's very straight question, easy question. Answer is 8 meters per second square. So fourth option is the correct answer.